5, we just get that EF is 7/5. And since by construction, ABEF is a rectangle, we get that AB is equal to EF, and we just found EF to be 7/5, so AB is equal to 7/5. Now the problem is asking for AB times CD, and earlier we found that CD is equal to 5, so our answer is just 5 times 7/5. Okay, the next problem we'll be going over is problem 15 on speed round. So basically, the problem is that a 2x3 grid of squares, we basically have a 2x3 grid of squares, and each square is colored red or blue by random. And we want to find the probability that at least one of the rows has all squares colored the same color. And yeah, we just want to find that probability. So instead of us trying to compute the probability that at least one of the rows has the same color, let's try to compute the probability that none of the rows have the same color. And we see that each row, since it has 3 tiles, it can be colored in 2 to the 3 is equal to 8 ways. So this is the number of ways each row can be colored. And 2 of these ways will have all of the rows the same color. So we can either have RRR, BBB. So these are the 2 ways that we have the same color. So now from this we see that there's a 1/4 chance or 1/4 probability that the tiles in a row have the same color. So using this, we see that there's a 3/4 chance that a row has tiles of different color. And since we have 2 different rows, there's a 3/4 squared, which is equal to 9/16, a chance that all the rows will have different colors. And as we saw, we just calculated the complement of the answer. So our answer is just 1 minus 9/16, which is 7/16. So the answer is 23. Next problem we'll be covering is the 17th problem on the speed round. So basically in this problem, we have a triangle ABC with AB is equal to 9, BC is equal to 15, and AC is equal to 16. And we have point D being an interior point in the triangles such that it lies on both the median of side AB and the angle bisector of BAC. And we have E being the point on side BC that lies on AD. Then finally, we extend BD to point F on AC, and the problem is asking us to find C, the ratio CF is to BE. So if we draw it out, this is the diagram, and it's asking us to find CF is to BE. And you may notice these circles, and basically this is the problem we'll be applying mass points to. So, let's let the mass on point B be 16. And by the angle bisector theorem, we have that 9 over BE is equal to 16 over CE. So we have that BE is to CE is 9 is to 16. So they're in a 9 is to 16 ratio. So from that, we see that the weight on point vertex C has to be 9. And now again, since this line through C bisects AB, we have that the mass on A would also be 16. So now we have the masses of all the vertices. So the next step would be to calculate BE. So how do we calculate BE? We have this equation here, and we have that BE plus CE is equal to 15. Now you can easily solve these system of two equations using elimination, and by doing this we get that BE is equal to 27 over 5. So now since we know the weights on A and C are 16 and 9 respectively, we know that CF is to AF is equal to 16 over 9, because we know this and this. And we also know that CF plus AF is equal to 16. So now using these two equations, we get that by the same approach we used to solve the first system of equations, we get that CF is equal to 256 over 25. So we found CF and BE. So the ratio CF over BE is 256 over 25 times 5 over 27. And if you simplify this, this comes out to 256 over 135. Oops. So our answer 256 over 125. So our answer is just 256 plus 125, or 391. Okay. Next problem is problem 18 on the speed run. So the problem is asking how many ways can we choose three subsets A1, A2, and A3 from the set 1, 2, 3, such that A1 is a proper subset of A2 and A2 is a subset of A3. So basically, recall that a proper subset is just a subset that does not have the same number of elements or is just not the whole set. So we in this problem we proceed by casework, and each of the cases are the different sizes of the sets. So we must have that the size of A1 must be less than the size of A2, and the size of A2 must be smaller than the size of A3. So I'll list our cases. So our first case is that A3 has size 3, A2 has size 2, and A1 has size 1. So this is our first case. How many ways can we do this? Well, since A3 has size 3, we only have one option for A3. A3 must be equal to the whole set. Now for A2, um, we have three choices because we can choose any two elements of the whole set. So A2 is, we have three choices. And for A1, since it cannot be uh, since it has to be a subset but not a proper subset, A1 just has to be one of the elements of A2. So A1, for A1, we have two choices. So in total for this case, we have 1 times 3 times 2 is equal to 6. Okay, let's do case 2 up here. So our second case is that A3 again has size 3. A2 has size 2 again. But now A1 has size 0, so A1 is empty. So A1 is empty. So for this case, we basically have the same number of ways to choose A3 and A2, except now for A1 we only have one choice since it's empty. So we had 1 times 3 times 2 in the first case. Now we'll just have 1 times 3 times 1, which is 3. Okay, now for the third case, we have that A has size 3, A2 has size 1, and A1 has size 0. For this case, A3 is again fixed since it has 3 elements. E2 can be any element uh, of the set. So A2 can be 3 ways. Again, we had A3 can be chosen 1 way. And then since A1 has size 0, it's empty, so it's just 1 way. So the total for this case is again 1 times 3 times 1, which is 3. Finally, for the last case, we have that A3 has size 2, A2 has size 1, and A1 is empty. So now there's 3 ways to choose A3 since uh, we have 3 choose 2, which is equal to 3. So A3 has 3 ways. A2 uh, A2 we can choose in 2 ways because it just has to be one of the elements of A3. So this can be chosen in 2 ways. Now since A1 is empty, we have 1 way. So 3 times 2 times 1 is 6. So if you've been counting, in total, our 4 cases where we've come to 6 plus 3 plus 3 plus 6. So this comes out to 18. Okay, the next problem is number 19 on the speed round. So in this problem, we have 2 real numbers, and we're randomly choosing them exclusively between 0 and 1.9, and we want the probability that the sum of the 2 numbers is greater than their product. So to proceed, let the 2 numbers be A and B. So then we have the inequality A plus B is greater than AB. So this is the sum of the 2 numbers is greater than the product. So first, let's try to solve the equality, which is A plus B is equal to AB. Now, to solve this, we can just do some factoring. So bringing the B to the right-hand side and factoring, that gives us B times A minus 1 is equal to A. And now, so we get B is equal to A over A minus 1. And if we split the numerator, we get that B is equal to 1 plus 1 over A minus 1. And now we can plot this, and this is basically a hyperbola, kind of like the graph of 1 over x. And so it's basically the graph of 1 over x translated 1 unit up vertically and 1 unit up horizontally, since you have this minus 1 here and the plus 1 here. So this is shown on this slide. So this is the plot of y is equal to 1 plus 1 over x minus 1. So to find the vertices of these hyperbola, we notice that the hyperbola should be symmetric across the line y is equal to x, as a and b are just variables and interchangeable. So if we plug in a is equal to b into the equation, b is equal to 1 plus 1 over a minus 1, and by doing this, we get the b plus b is equal to b squared. So this by factoring, we get the quadratic b minus 2 times b is equal to 0. So the solutions are b is equal to 2 and 0. So our two vertices are 0, 0, and their vertex is 2, 2. So now, what did the problem ask us? It asked us for the bounds, and the bound was basically 0 and 1.9. So a and b must be in between these two. But if you notice, this box right here, the 0 to 2 box, includes this range 0 to 1.9. So that basically means that the area, our sample area, is just inside this box. And what's the area where the sum exceeds the product? The area is here. It's below the bottom parabola and above the top parabola. So essentially, or never mind. It's actually the complement of this. So this is where the sum is less than the product. So if you take the complement, this is the area where the sum is greater than product. So since this area includes the box, our answer is just, the probability is just 1. So it's asking for percent, so 100%. Okay, I'm gonna let Divya start from here and do this problem.
Okay, so now we'll go over speed number 20. So the problem is Reese and Kevin play the following game. Each roll a blue die and a red die are rolled. Or each roll a blue die and a red die. Each of their scores is the value of the blue die divided by the value of the red die. The probability that Reese obtains a greater score than Kevin can be expressed as m over n, where m and n are relatively prime positive integers. Find m plus n. So basically in this game, there are 3 scenarios. Either Reese wins, Kevin wins, or they tie with each other. So by symmetry, we have that the probability that Reese wins is the same as the probability that Kevin wins, because they're doing the same thing to get their scores. So let that probability be P. So the probability that Reese wins or Kevin wins is P. And then let's call the probability that Reese and Kevin tie. Let's call that Q. Then, because these are all 3 scenarios, these probabilities should add up to 1. So we have the probability that Reese wins is P, the probability that Kevin wins is P, and the probability that they, one second. Here we go. Okay, so the probability that they tie is Q. So these should add up to 1. So we have 2P plus Q is equal to 1. So we can solve for P in terms of Q to get that 2P is equal to 1 minus Q, or P is equal to 1 minus Q over 2. So this tells us that to get the probability that Reese wins, we can just find the value of Q and then substitute that into 1 minus Q over 2. So now we can try to find the probability that they tie. So basically there's only a couple fractions that have different possible rolls and they get the same score. So the first such score is 1. So to get 1, you could roll a 1 and a 1, a 2 and a 2, 3 and a 3, so on, to a 6 over 6. Because to get this score, the value of your first roll divided by the value of your second roll should be 1. That just means the values on your 2 die should be the same. So they can get a 1 in these 6 possible ways. And then the next such score would be 2. you can get a 2 by getting a 2 and a 1, a 4 and a 2, and a 6 over 3. And then next week, they can get a 3 and tie by getting a 3 and a 1, and a 6 and a 2. So these are the only integer scores they can get and tie. And then we see that they can also get 1/2 in multiple ways by getting 1 over 2, 2 over 4, and 3 over 6. And then similarly for 3/2, they can get 3 over 2 and a 6 over 4. And then for 1/3, you can have a 1 over 3 and a 2 over 6. And finally, the last case is 2/3, which can be done by 2 over 3 and then a 4 over 6. So basically, these squared values are all the values such that you can obtain different pairs of roles and still get the same value. So they can either tie by getting 2 different values in the same group. So like Reese can get 1 over 1 and Kevin could get 3 over 3, and they would tie because those fractions are equal. So the first way they can tie is to get distinct fractions in one of these groups. So the group I'm talking about are these set of fractions. So, for example, Reese could get 1/2 and Kevin could get 3 over 6, and they would tie because both of those are 1/2. And then the second way they can tie is just by rolling identical dice. So like if Reese were to roll a 5 and a 6 and Kevin were to also roll a 5 and a 6, their scores would be the same. So the second way is that they would get the same exact rolls. So the probability that they get the same exact rolls is 1 over 36, because Reese can get 36 pairs of rolls because there's 6 ways for each roll. So that's 36. And then Kevin has to get the same exact pair. That's how we get 1 out of 36 for this second case. And for the first case, they get distinct fractions in a group. So first, let's count the number of fractions in each group. There's 6 for this group because 1, 2, 3, 4, 5, 6. There's 6 there. There's 3 here. There's 2 here. I'm just counting the number of fractions in each of these lines. There's 3 here. There's 2 here, 2 here, and then finally there's 2 here. So basically, let's say that, just to generalize, there's n fractions in a certain group. Then Reese can get any n of those fractions, but then Kevin can only get n minus 1 of them since they have to be distinct. Because if they got the same rolls, that's already counted in this second case. And then we divide that by 36 times 36 because each of Reese and Kevin have 36 possible pairs of die. So this would be the probability of getting distinct fractions in a group of size n. So now we need to sum this up for all of these groups, all of these 7 groups. So basically we get 6 times 6 minus 1, this is for the first group, over 36 squared, plus for this group, we get 3 times 3 minus 1 over 36 squared. And we just sum this up for all 7 of these groups. And that gives us 50 over 36 squared. So this is the probability that this first case happens, is 50 over 36 squared. So now for our final answers, we can sum the probabilities we found for the first case and the second case. And this gives us 43 over 648. But remember that this is our value of Q, or the probability that they tie. But the question asked for the probability that Reese wins. And remember that that probability is equal to 1 minus Q over 2. So we need to find 1 minus 43 over 648 over 2. And computing that gives us the answer of 605 divided by 1,296. And the question asks for the sum of the numerator and the denominator. So that's 605 plus 1,296 to be 1,901. So that would be our final answer to the problem. So now we'll go over focus number 1. So the question asks, find the number of 11-digit positive integers such that every 3 consecutive digits form a palindrome. And a palindrome is a number that reads the same forward and backward. So basically, you can just draw out the 11 digits. So let's say the first digit is A. So we need to have every 3 consecutive digits forming a palindrome. So we can call the second digit B. And since this first 3 digits has to be a palindrome, our third digit has to be A, because this must be a palindrome and our first digit was A, hence our third digit must also be A. Now this number has to be a palindrome as well. And since our second digit was B, our second and fourth digit have to be the same because this has to be a palindrome. So we get this has to be B. And basically, if we keep doing this, we see that we just get a number of the form AB, AB, so on. So basically, we just need to compute the number of 11-digit numbers in this form, where basically the digits are alternating. So the first digit has to be 1, 2, all the way up to 9. It can't be 0. So we have 9 options for the first digit, or for A. And then for B, B can be 0, 1, 2, or basically it can be any digits, because it can be 0 because it's not the first digit of our number. So we have 10 options. So basically B can be any digit and A can be any digit but 0. So for the total number of numbers, we multiply 9 and 10 for the number of options for A and B, and this gives us an answer of 90. Okay, Anant will be taking over now.
Okay, so the next problem we'll be doing is focus number 2. So this problem, we have a function f over the positive integers, where f of k equals the sum of the digits of the number 111 squared, where there are k ones in that number. So if you compute this, we have f of 1 is equal to 1, f of 2 is equal to 2, f of 3 is equal to 9, and so on. So the problem is asking us to find f of 1 plus f of 2 plus all the way up to f of 9. So this problem basically can be solved by noticing a few patterns. So let's look at let's look at the squares of these numbers. So we have 1 squared is equal to 1. 11 squared is 121. 111 squared is equal to 12321, and then 1111 squared is equal to 1, 2, 3, 4, 3, 2, 1, and so on. So basically, using this, we can predict that 9 ones. So there are 9 ones here. Is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. This big number. So now that we know what all of these numbers are, let's try to find the sum of these digits. So that's just the function. So the sum of digits of 1 is just 1, so we have f of 1 is equal to 1. From this, we have f of 2 is equal to 4. From this, we have f of 3 is equal to 1 plus 2 plus 3 plus 2 plus 1. That's 9. Compute the sum of digits here, it's 16. And basically the pattern is that f of k is equal to k squared. This is pretty easy to prove. So to show this, we essentially have to show that 1 plus 2 plus all the way up to k plus k minus 1 plus k minus 2 plus all the way up to 1 is equal to k squared. And this is pretty easy to show using the identity that k times k plus 1 over 2 is equal to 1 plus 2 plus. So now that we've established that f of k is equal to k squared, we essentially just need to find 1 squared plus 2 squared plus 3 squared all the way up to 9 squared. Now, if you remember the formula that 1 squared plus 2 squared all the way up to k squared is equal to k times k plus 1 times 2k plus 1 over 6, our answer just becomes 9 times 10 times 19 over 6. And if you evaluate this, this is just comes out to 285 because this 19. Okay. The next problem on focus asks us to find the last 2 digits of the number n, where n is given by this expression. So to find the last 2 digits of any number, we want to find the remainder when that number is divided by 100. So in this problem, we essentially just use Euler's theorem, which basically says that a to the phi of n is congruent to 1 mod n if a and n are relatively prime. So the phi function is called Euler's function. You can just get that from the prime factorization of n. So let's apply Euler's theorem to this problem. We have, let's look at the last 2 digits of 2021 to the 2021. So this, mod 100. So we can take the base mod 100 to get that this is equivalent to 2021 to the 2021 mod 100. And now notice that let's calculate. Notice that 21 and 100 are relatively prime, so we can apply Euler's formula here. So we have that 100 is 40 because 100 is just 2 squared times 5 squared. So 1 plus 2 plus 4 times 1 plus 5 plus 25. Or, no, it's not 2 squared times 5 squared. It's 2 cubed. Whoops. Yes. Yeah, so basically we get 5, this is 40. So now to compute 21 to the 2021 mod 100, we take the exponent of this. So 2021 mod 40, that's just 21. this is just equivalent to 21 to the 21 mod 100. So now how do we evaluate this? Let's go up here. So to evaluate this, we can use the binomial theorem. So 21 to the 21 is just equal to 20 plus 1 to the 21. And by expanding this, we see that there'll be, most of the terms will be divisible by 100. In fact, all of the terms except for the last two will be divisible by 100. So if we take the modulo of 100 of this, we should get the last two terms. So the last two terms are just 21, choose 1 times 20, and then 1. So it's equivalent to, if you compute this, this is 421. And 421 mod 100 is just 21. So now we found the last two digits of this term are 21. Now if we notice, the last two digits of all these other terms will be the same, because for example, look at 1021 to the 1021. It has a remainder of, the base has a remainder of 21 when divided by 100, and the exponent has a remainder of 21 when divided by 40. So after applying Euler's theorem, all of them boil down to 21 to the 21 mod 100. So each of these four terms has last two digits being 21. So the last four digits of or the last two digits of n would just be 4 times 21, or 84. Okay. The next problem is a geometry problem. So in this problem, we have that A, B, C, and D are points on a circle, and we have point E being the intersection of AC and BD. And we're given that DE is equal to 6, AE is equal to 3, EC is equal to 10, and angle CBD is equal to 90. And we're asked to find the radius of the circle. So using this, we get this diagram right here. So to find the radius of the triangle, we would want to try to look for some isosceles triangles. And so yeah, since we have that C, B, and D lie on the circle, we can we know that CBD is equal to 90, and since CD is the diameter of the circle, that just follows from the result that like a 90-degree angle implies that the points lie on a circle. So basically we have that CD as a diameter. So now this also means that CAD is equal to 90, because an inscribed angle in a semicircle is always 90 degrees. So now we can use the Pythagorean theorem on triangle DAE. We know that DA is equal to 6 and AC is equal to 13. So CD or we don't, never mind. We don't know DA, but we know DE. So DE is equal to 6 and AE is equal to 3. So triangle DAE is just a 30, 60, 90 triangle. So by applying the ratio, the 1 is to root 3 is to 2 ratio, we have that AD is just 3 root 3. So now we want to apply the Pythagorean theorem on triangle DAC. So we have AC is equal to 13, D a is equal to 3 root 3. So now applying the Pythagorean theorem, we have CD is equal to the square root of 13 squared plus 3 root 3 squared, and this is just 14. So CD is equal to 14, and since CD is the diameter, the radius is just 7. Okay, next problem. So this is a 3D geometry problem. So in this problem, we have an isosceles trapezoid ABCD with AB is equal to 2, CD is equal to 4, and AD is equal to BC. And we also have that angle ABC is equal to 135. And so we have, essentially, we just want to find the volume of the solid when created by rotating the trapezoid ABCD alongside BC. So to visualize this, we have the two diagrams right here.
Sorry, we're having some technical difficulties. Give us a few moments while you work some things out. Okay, we're just going to move on to the countdown round now, actually. So we'll be posting the answers and solutions to all of the problems after the meeting is over. So for the rest of the focus round problems, you can check the solution document. Okay. Right now, we're going to start the countdown at 4 o'clock, just to give some time for more people to join the call. And I'll send the bracket for the countdown in the Zoom chat right now. Yeah, we'll probably adjust the countdown round brackets to account for the people that aren't in the Zoom call. Okay, we're going to get started now. And the link to the spreadsheet is in the chat. Since we're not going to share it during the countdown. Okay, so before we begin, there are a few rules that we're going to go over first. So each round will consist of 2 players. There are a total of 7 rounds. In the first 4 rounds, the winner will be the participant who gets the most correct questions out of 3 questions. If participants are tied after 3 questions, the first person to get the next question correct advances. In the last 3 rounds, it changes, so the winner will be the participant who gets to 3 correct questions first. And the people that are participating should have their mics unmuted during their rounds.
And for clarification, the first 4 rounds will be the quarterfinals, and the last 3 rounds would be the semifinals and finals. So participants have 45 seconds to answer each question. And to answer, the participant must first type X in the Zoom chat. This is because we can see which one has an answer first, so we don't have like 2 people speaking at the same time. Once acknowledged by a moderator, which would be me, the participant should verbally say the answer within 3 seconds. Also, note that Divya will announce when there are 5 seconds left. If a participant gives the wrong answer, they cannot answer again for that question. And if they answer incorrectly, the other participant will have the remaining 45 seconds to answer, unless they have also already answered. Spectators who interfere with the competition by revealing answers on the Zoom chat or causing other disruptions will be disqualified. This also means that don't try to spam the chat when people are trying to answer. So don't worry. I can see who will like be able to answer, but don't spam the chat basically. So yeah, don't click. So looks like for our first round we will have Catherine and Abby. So Catherine and Abby, can you make sure that you you set an X so you are not AFK? Yeah, that'd be Catherine Zhu and Abby Grow. Okay. Ready for the first problem? You can go now. Oh, so what is 1 plus 1 minus 1 times 1 divided by 1? Catherine, what's your answer?
1.
Yes. So Catherine is 1, Abby 0. Okay. Whoa, careful.
We're going to skip the next question.
Okay. Okay. Sorry about that. Okay, I'm ready. How many ways can a club leader choose 2 of the 10 club participants to form a committee? Catherine.
45.
Yes. So Catherine is 2, Abby 0, and Catherine will move on. So our next match would be Lillian Xia and Nancy Naha. Can you press X on your chats? Those of you. Okay, what about? Never mind. We just wanted to make sure that you were not AFK. Are you both ready? Nancy's ready. Lillian, are you ready? Okay. Next question. If a cube has surface area 216, Lillian, what is your answer? Yes, it is 216. We would prefer that you say your answer, but it's also okay if you type it in the chat. Okay, so that would be Lillian 1, Nancy 0. Next question. Evaluate the product of that. Yes, Lillian? It is 0. So Lillian 2, Nancy 0. So Lillian will move on. Congratulations. So our next match is Jesse, Lee, and Florence. Can you both type something in the chats to see if you're not AFK? Okay. Okay. Are you both ready? Jesse, yes. Okay. Let me double check. Okay, so next question. A list of numbers starts off with 2 and 5. After the second number, each number in the list is calculated by multiplying the previous 2 numbers. So the third number would be 10. What is the sixth number? Jesse, what is your answer? Yes, that is correct. 25,000 is the correct answer. So Jesse will be advanced to 1, Florence stays at 0. Okay, next question. A specific heptagon has an area of 65. If each of the side lengths of this heptagon is doubled, but with each angle staying constant, what is the area of the new heptagon? Yes, Jesse? It is 260. That is correct. So Jesse advances with 2 questions correct. So congratulations. So our next match would be Richard and Flora. So can you both type something in the chat? Richard and Flora, can you please type something in the chat, please? Okay, Richard. Okay, so are you both ready? I'm gonna assume, Richard, that means a yes. So, okay, next question. A fair coin is tossed 4 times. What is the probability that an even amount of heads will occur out of these 4 tosses? Richard, what is your answer? That is incorrect. Flora, what is your answer? That is also incorrect. The correct answer is 1/2. Okay, next question. Find the area of an isosceles trapezoid if the base lengths are 1 and 2 and one of the interior angles measures 60 degrees. Flora, what is your answer? That is incorrect.
Five seconds.
Richard, I just want to say that you should press X when to buzz in, but unfortunately that answer is also incorrect. The correct answer is 3 radical 3 divided by 4. Okay, next question. One day in Iowa, the air temperature recorded was negative 35 Fahrenheit. 3 days later, the air temperature recorded was 37 degrees Fahrenheit. Richard, what is your answer? That is incorrect. Flora, what is your answer? That is also incorrect. The correct answer was a 1. Wait. Yeah. So we are now 0-0 after 3 questions. So this match is now sudden death. Next question. Find the closest integer to the solution x, and x cubed minus 3x squared plus 3x minus 1 equals 7,999. Richard, what's your answer? That is correct. So Richard is 1, Florence 0. So Richard will advance on. Congrats. So before we move on to the semifinals, I would like to say congratulations to Abby, Nancy, Florence, and Flora for doing well in this countdown round. And congrats for making the top 8. So the next match would be in the semifinals, Catherine versus Lillian. And we will note that from now on, each person has to get 3 questions correct in order to advance. However, the maximum, we will only have up to 7 questions per match. So yeah. Catherine and Lillian, can you please type something in the chat? Okay, are you both ready? Uh, we're gonna assume that's a yes. So yeah, let's start. Next question. The 7 books in the Harry Potter series has page lengths 607, 233, 636, 251, 766, 607, and 317. What is the difference between the median and the mode of the page counts? Lillian, what's your answer? It is 0. That's correct. So Lillian 1, Catherine 0. And Richard, yes, I actually did research those pages up. Next question. John has 60 marbles that he wants to put in some bags. If he wants to have each bag containing a different amount of marbles, what is the maximum amount of bags that he can use? Catherine, that is incorrect. Lillian, what's your answer? That is also incorrect. The correct answer is 10. But also, a side note, you can actually also do 60 because a bag can be placed inside a bag. Okay, next question. So it would be, wait, let me double check. So Lillian 0, Catherine 0. Lillian 1, Catherine 0. So next question. A line is drawn from the origin to 1620. Including the endpoints, how many lattice points does this line go through? Catherine. That is correct. So Catherine 1, Lillian 1. Next question. The product of 185 and x is a perfect cube. What is the smallest possible value of x if x is a positive? Oh, Catherine. Yeah, that is also correct. So Catherine 2, Lillian 1. Okay. You can go on. A 3x3 grid containing integers exist. The number at the top left corner of the grid is 1. Additionally, each integer on this grid is one more than the integer directly left of it, and one less than the integer directly above it. What is the sum of all the integers in this grid? Catherine. That is correct. So Catherine wins with 3, Lillian 1. Congratulations to both. Yeah, GG. So our next match is Jesse versus Richard. Can you both type something in the chats? Okay, are you both ready? Ooh. Okay, well, we're gonna assume that you're both ready to answer some questions. So let's move on. How many 5-digit numbers can be created if every single digit must be even? The number cannot start with a 0. Richard, what's your answer? That is correct. So Richard 1, Jesse 0. Okay, next question. Compute the remainder when 47 cubed is divided by 7. Richard, that is correct. Richard 2, Jesse 1. Yeah. Next question. Find the value of the following expression. Jesse. That is correct. Richard 2, Jesse 1. Yep. Okay, next question. What is the area of a rectangle whose perimeter is 20 and has all of its side lengths Jesse? You have 3 seconds to answer. Okay, 24 is correct. So that would be Jesse 2, Richard 2. Next person who answers the question correct will move on. Okay. Next one. Find the sum of the roots of x squared plus 10. Richard. That is correct. So Richard moves on with 3. Congratulations to both, by the way. And also a fun side note, that problem was a problem that was very, very similar to what a problem that I got in Math Counts State Countdown. And I had no idea how to solve it because I didn't know what Venus theorems was. Okay, so Richard moves on to finals. So our finals is Catherine versus Richard. Oh, can you type something in the chat? Okay, are you both ready? I'm gonna say no, but I'm just gonna assume that is a yes. Okay. Okay, let's start. Find the sum of the distinct prime factors of 2020. Richard. That is correct. 108. So Richard 1, Catherine 0. Okay, next question. 6 people, including Kevin and James, are randomly seated at a circular table that has, what is Catherine? That is not correct. Oh,
Time.
So the correct answer is indeed 3/5. I'm sorry, Catherine, but we cannot accept that. Okay, next question. How many ways are there to arrange the letter sequence corona if the first letter must be a consonant? Catherine. That is correct. Catherine 1, Richard 1. Okay. We just love making questions, Abby. Okay, next question. The angles of a triangle form an arithmetic sequence. If the smallest, Catherine. That is correct. So Catherine 2, Richard 1. Okay. Okay. Next question. Catherine, if Catherine gets this correct, she will be the winner. Next question. A rectangular prism has dimensions lengths, widths, and height. If L plus W plus H equals 10, and if the surface area of the prism is Catherine. That is not correct. Richard. That is also not correct. The correct answer is 60. So Catherine is 2, Richard 1 still. Okay, next question. A number is randomly chosen from 1 to 100 inclusive. What is the probability that the number is relatively prime through 10? Catherine. I'm sorry, but that's incorrect. Richard. That is also incorrect. The correct answer is 2/5. So Catherine stays at 2, Richard stays at 1. Next question. There is a tiled grid with dimensions n by m, such that there are 30 tiles that do not touch the edge of the grid. What is the smallest possible? Richard. That is incorrect. Wait. Give me a moment. I think this might be something wrong with the answer key. Yeah, never mind. Yeah, I'm sorry, but it's wrong.
Time.
The correct answer was 56. Okay. Next question. A chess knight can move to any last point square root of 5 units away in each move. For example, a knight at origin can move to 1 Catherine. That is correct. So Catherine wins with 3. Richard stays at 1. And congratulations, Catherine. Also, congratulations to Richard for making this far. Yeah, GG to everyone.
Congratulations to everyone that participated. Give us 5 minutes to set up the awards presentation. All right, everyone, we're ready to present the awards now. Everyone will be receiving award certificates afterwards, which we will email to you privately. In addition, the top 3 scores in each test, so in the speed and in the focus rounds, will also receive printed copies of the our math book when that is published. Okay, so we'll first start with the speed round. In third place, we have Richard Yang with a score of 10 out of 20. In second place is Lilian Xia with 13 out of 20. And the first place speed round score is Catherine Xu with 18 out of 20. Okay, moving on to the focus round. We had a tie for second place between Lillian and Jessie Lee with the scores with both with scores of 18 out of 30. And the top focus round score was Catherine with a score of 24 out of 30. I will move on to the individual round scores now. In third place, we had Jessie Lee with a score of 27 out of 50. In second place is Lillian with 31 out of 50. And the first place individual score was Catherine with a score of 42 out of 50. We'll now move on to the countdown round results. So our quarterfinalists were Abby Guo, Nancy Nara, Florence He Yu, and Flora Zhu. Moving on to our semi-finalists, we have Lillian and Jessie. In second place is Richard Yang, and the countdown round winner is Catherine Xu. So thank you all for participating, and congratulations to everyone that participated. So the book award winners will be Lillian, Jessie, Richard, and Catherine. And they will receive printed copies of the book when it is published. However, the book will also be free and online as well, for those of you that are wondering. In addition, we will also be posting all of the problems and solutions on our website shortly after the meeting is over. But we'll leave it open for now in case you guys want to chat. And the Math Circle is going to resume next weekend. So we hope to see all of you then again.
Yep. So I'm just kind of curious. What do you think about the countdown round this time? Like, do you think it's better than Math League's countdown round?
No, we didn't get to the fun problems in the countdown round. Do you guys want to see some of them?
Yeah, it's. Oh yeah, go ahead.
Oh,
Oh boy.
let's see.
We will like having fun making
They
toys.
were really. Oh, here's one of them. Okay, let's see. What else do we have?
Keep going. Yeah.
Oh yeah, there's this one.
Richard?
And also, oh, this one. Yeah, this is a fun one. You guys can check out all of the countdown questions when we post the slides to the website, and all of the answers will also be available. Yeah, and you guys saw the Kevin and Herbert